divide and conquer strategy is a useful technique which is applicable for, is used to solve many problems in data structure, especially in algorithm. So what is divide and conquer? Divide and conquer is an algorithmic paradigm in which the problem is solved using divide, conquer, and combine strategy. So a typical divide and conquer algorithm solves a problem using following three steps. First step is divide. So we'll be dividing the problem into sub-problems, smaller sub-problems. And when they will be too small, then we'll solve it. And then like this, we'll actually solve the larger problem. Then conquer, solve sub-problems by calling recursively until solved. So here the recursive technique is useful. It is not that always we should be using recursive algorithm to solve divide and conquer, but 90% cases we use recursive algorithm. So we have to understand recursive algorithm very thoroughly. Otherwise, directly jumping on divide and conquer strategy, it will be difficult to understand. So first you have to understand the recursive algorithm. So that is the conquer technique. That means you have to solve the individual problem using recursion, and then finally combine the sub problems to get the final solution of the whole problem. So finally we'll combine the sub problems to get the final solution. So what exactly happened in divide and conquer strategy? Divide instances of the problem into two or more smaller instances. Solve some smaller instances recursively. As I said, most of the times we will be using recursive technique. So if we don't have understanding on recursive technique, no way you are going to understand there is no point learning divide and conquer strategy. Not only that, recursive algorithm has to be understood, because next we have this dynamic programming, 3D method. All this technique uses recursive technique. Although iterative technique we can use, but recursive algorithms, recursive functions. So the implementation of recursive function in C, that has to be cleared. Understanding should be thorough. Otherwise, there is no point doing a lot of mathematics on recursive algorithm. Obtain solution to the original instance by combining this solution. Now, if you see the divide and conquer technique example, how it operates. So we have the problem size of n. Then we divide the problems into sub-problems, sub-problem 1 and sub-problem 2. Here sub-problem is divided by n by 2, n by 2. Actually, this is not necessarily that every time we will be dividing the, most of the cases we divide the problem by half, but it is not, it may not be the true for all cases that we will be dividing the problems by half. We might divide the problems by 1/3, 1/4, depends on the problems and the solution. But here let us assume that we have divided the sub problems into n by 2. These sub problems also, these sub problems n by 2 one side, n by 2 another side. Then a solution to sub problem 1 can be done using recursive algorithm. This is sub problem 1, which is sub problem 2. And then you can recursively solve this sub-problem 1 and sub-problem 2. It is just a tentative diagram, that means it's not precise. So you can further solve this sub-problem 2 into sub-problem n by 4, n by 4 like. And finally a solution to the, so this sub-problem 2 you solve it, sub-problem n by 2 you solve it, this n by 2 problem you solve it, and then finally you get the solution, original solution to the original problem. Now, when the sub-problems, one thing to be mentioned in divide and conquer strategy is that sub-problems are independent sub-problems. Sub-problems are independent sub-problems. That means sub-problem doesn't share the, so which is unlike in case of dynamic programming. So when the sub-problems are large enough to solve recursively, we call that sub-problem, that the recursive case. We call that the recursive case. That means that is when sub-problems are large enough, then recursive technique is the best suited technique for it. Once the sub-problems become small enough that we no longer recurse, we no longer recurse it. We say that the recursion bottoms out. Like in case of factorial, today we are going to see factorial, how to find the factorial of a number using recursive algorithm. And the meaning of this thing is that when the subproblems become small enough, that means when the factorial 0 or factorial 1 will come, that time, that is the termination point. So when the termination point reached, we will call it the recursion has bottoms up out. That means there is no further, we cannot do further recursion, and that we have gotten down to the base case. So that termination point is called base case. So every recursive algorithm will be having a base case. In case of linear recursion, I'm talking. Okay. Sometimes in addition to the subproblems that are smaller instances of the same problem, we have to solve subproblems that are not quite the same as original problem. Okay, so as I said, let's say here subproblem is n by 2, this also n by 2. The solution will be similar. Solution will be similar for it. But let's say if this is n by 3 and the remaining will be how much? Not n by 2, right? Something else. Not n by 2. So in that case, it will be unequal. The subproblems are unequal. So subproblems are of not same nature. So subproblems that are not quite the same as original, we consider solving such problems as a part of the combined step. That has to be taken care in the combined step. Now, divide and conquer, D and C. Let's say this is problem P. If problem P small p, then return SP. Like in case of factorial, small p is nothing but the termination, the base case. That means when it is factorial 1 or factorial 0. Else divide p into smaller instances p1, p2 to pk. The k is greater than 1. Apply divide and conquer strategy to each of these subproblems. That means p1, p2, p3 will solve it and return combination of all solutions of the small subproblems that will be returned, and finally you will get the result. So small p is a Boolean value. Actually, when it will go to the base case, that means in case of factorial that we are going to see, it is in base case that will be like a Boolean. So finally, when it will reach to the bottoms out, as it said, it is bottoms out. We call it bottoms out. That when it will reach there, like 0 or 1, that time what happens? That time that will be the answer will be Boolean. That means either 1 or 0. Either 1 or actually most of the cases 1 or maybe 0. That will be the result. The result will be Boolean. The return value will be Boolean, and that is the termination point of base case. If this is so, function S is invoked. Otherwise, the problem P into smaller subproblems. These subproblems P1, P2, Pk are solved recursive application of divide and conquer. That means this has to be this P1, P2, P3 all has to be calculated recursively. So what are the famous divide and conquer applications? Binary search. Binary search, many of you know that every time the element, first of all in binary search what happens? Sort the array. Sometimes students does mistake. The binary search cannot be done in a random array. Whenever binary search has to happen, the array has to be sorted. So once it is if array is sorted, then we can say we can directly, instead of searching some particular element in the array, we can directly go to the midpoint, and if the midpoint value is less than, if the element that we are going to search is less than the midpoint value, then we'll ignore the right value after midpoint. That means half of the array we'll ignore. We'll just concentrate on the first half of the array. That is how binary search happens. Then again we'll get the midpoint like that. Today we are going to see this. Then one of the famous sorting algorithm also there, which is called merge sort, that we will be discussing in the next class, which uses divide and conquer strategy. Quicksort algorithm, Fashion matrix multiplication, Arastuba algorithm. So these two are matrix multiplication algorithm which are there in the syllabus. Alongside also you have to learn this technique, these problems, and how divide and conquer applications, divide and conquer technique used for it. So recursion, let us revisit the recursion. Many of you might be already knowing the recursive function. So the process in which function calls itself, because without recursion nothing can be done in divide and conquer and in dynamic programming and in all other related problem algorithm design analysis. Without recursion, it is not wise to study. So the process in which a function calls itself directly or indirectly is called recursion. Function call itself directly or indirectly. Indirectly in the sense function may not call, function is calling another function, that function is calling something else. So that is in a way a recursive call. Not necessarily that function is calling itself, but function is calling some function, that function again calling you, something like that. Direct, indirect calls are also possible. Using a recursive algorithm, certain problems can be solved quite easily. Recursion is an amazing technique with the help of which we can reduce the length of our code and make it easier to read and write. It has certain advantages over the iteration technique, which will be discussed. So a task that can be defined with its similar subtask, recursion is one of the best solutions. So divide and conquer strategy uses independent subproblems. That means whenever we have a subproblems P, let's say problem P is divided into 5 problems, P1, P2, P5, and P1 and P2 should be independent subproblems, P1, P2, P3. So what can be the, actually recursive algorithm should be, we should be able to, as a programmer or as a developer, able to develop recursive algorithm for any sort of, if it is additive, I mean, any sorts of problem, there should be recursive solution, but in real case, it might not be possible to develop recursive algorithm all sorts of, but theoretically it should be. So adding two numbers together is easy to do, but how to add a range of numbers? The following example, recursion is used and add a range of numbers together by breaking it down into the simple task of adding two numbers. So basically, we are going to see how recursion can be used for even adding two numbers. So here you can see that this code where this is nothing but addition of 10 numbers, natural numbers 1 to 10. Okay, 1 to 10. So you can see that this is a C program, and for C programs I haven't I'm not going to show, I'm not telling this just for the C program. This is just I'm to show you the recursive call. So here you can see that is sum 10. So this is the function sum, definition of sum. So int sum, int k. So when you are passing 10 here, so 10 actually is, so this is a recursive call. So 10. So what happens if k is greater than 0? So now this is 10, k is 10, so 10 is greater than 0, which is true. Return k plus sum k minus 1. Again here one call is there. So 10 will become 10 minus 1, 9. But this k has been released. That means the first, you can call it constant, because first it is 10. So k has been out from the recursion. This recursion has been developed such a way that k 10, the digit 10 is out, and then with that again another call is happening, because it is the function definition. Within the function definition, another call which is sum. Again function is calling sum. That means again this function is 9. So 9 will come. 9 will be released. That means here 9, then 8, then 8, 7, 7, 6, like that. So sum 10 plus sum, 10 plus 9 plus sum 8, 10 plus 9 plus sum. So here function recursive call is happening, and then finally 10 plus 7, 6, like that. It is decreasing by 1 every time, and but the function call is still there. This is function call. This you have to understand. So here it's nothing but sum is nothing but sum of k, nothing but k plus sum k minus 1. This is the linear equation, linear recursion. Sum of k equal to k plus k minus, sum of k equal to k plus sum k minus 1. So here, and then finally when it will be 1, when k will be 1, it will be 1 plus sum 1 plus 1. So when 1 minus 1 happens, it is nothing but 0. So the 0, when it will try to call, because this is again a call, so this 0 is not greater than 0, it will be false. So it will return 0. When it will return 0, that's all. This is the termination. But whichever the value it has calculated, that will be returned. That value we can see. So 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. So since the function does not call itself when k is 0, the program stops there and returns the result. So whole results will be returned. Okay, whole results will be returned. So I'll just show you. So here you can see same thing. So it is 55. That means the total, this thing is 55. This is the recursive program. So this understanding of recursive program is very important. So in fact, you can, after the class, you can go and read recursive program. What is the basic understanding of recursive and all these things you understand, because next time I'm going to discuss dynamic programming, matrix and multiplication, and longest common subsequence. Full recursion used. And understand. So binary search using recursion. So in binary search, what happens? Here, let's say I'm going to search 46. So in binary search, what happens? Here, basically we have this low, we have this high. So high plus low, we get the midpoint. Midpoint we get, and then in the midpoint, first try with the midpoint. With the midpoint index itself is the value that we are searching, which is 46. It is not the case. So index 5, the midpoint, which is 31. 31 is less than 46. And as I said, whenever you are going to implement binary search, because there are two searching algorithms majorly we know. One is linear search, another one is binary search. So in binary search, and it uses recursive algorithms. So whenever we have 46, 31 is the value, and it is a sorted array. So what this recursive algorithm, because then it actually, this is a divide and conquer strategy. So we are going to divide this array, the midpoint, thinking that either in the left side of the array or right side of the array, we will get a desired element that we are searching, which is 46. But 31 is less than 46. So what we will do, we will just ignore this complete ignoration of the first part of the array, first half of the array. Rather, we will check the remaining part of the array. So the high will remain same. The low will be shifted to this 31. So low in fact can be shifted to mid plus 1, which is 4. Now this whole array, which is in the left side of my left hand side, we ignore. Rather, my new array will be 40 to 49. Now again I'll get the midpoint. My midpoint will be 42, which is again 42. This is also not matching, so a low will be shifted here. High will be as it is. So low, yeah, and now next time the midpoint will be, a low will be shifted here. So midpoint will be again this 9 plus 6 plus 10 minus 6 by 2, which is 8. 8 is the midpoint, but 8 also not matching. Then finally low will be shifted here in the first, and then low plus 9 plus 10 by 2, it will be like that only. 9 minus by 2, which is 1 by 2, which is floor value will take immediately in this place it will get. Okay, so we'll just I'll show you one code, binary search, you will understand it better. So here see, you can see that this is the, so initially what we do, whichever, always remember in binary search, which is a divide and conquer strategy, sort the array in ascending order. That means whichever elements we have, that sort in ascending order. That means 1, 2, 3, 4, 5, 6. Because otherwise there is no midpoint business will be successful, because we are taking midpoint we are taking and we are ignoring one part and we are considering the other part. This will only happen if your array is sorted, otherwise it is not. Sometimes this question asked in the interview and placement, people used to forget that binary search has to be sorted first. So any sorting algorithm you can use, bubble sort is used here. So first I am sorting here. array is getting sorted. So here you can see this list is the array which is holding the number of elements, and then and here is the main function. So here all the values are getting scanned, and list is passed. That means the array is passed. Size of the array. So size of the array. Okay, then size of the array. Yeah. So you have to give the size of the array. Let's say 5 or 4 or whatever. And then size of the array, and then enter the element we search here, and then list pass, size of the array passed, and the key passed. So this is 0 is initially that low thing that I am showing you. This low initially index is 0. So this index is has been passed. Size is total size. That means in this case it is 10. 10 will be passed. Take this array, and then call happens here. You can see the main function binary search call. This is the call, right? Recursive call. This is not a normal call. It's a recursive call. Binary search. Here it is recursive call. This call happens here, and then every time low equal to high, the midpoint they're getting. See, low plus high by 2, you are getting the midpoint. If the key is directly in the midpoint, we found it. Otherwise, if key is right side of the array, then it is midpoint right side. Just now I shown you this right side of the array. So our element is 46, so 46 is right side and is left side. Okay, means the key is in left side. So if it is left side, then again binary search call happens. So here one call binary search inside the definition of the function. Here again on binary search call happening here. Okay, this is a recursive call. Like this it will go. When it will terminate, it will only terminate. It will only terminate if any of the condition is true. If it will keep going, and then finally yeah, if it is found the key, then key found. That's all. Final thing. Okay, this is the termination. If it finds the key, if it not find the key, then it will print not found, key not find, which is unlikely the case, because you won't be going to write a code which is failure. Like you will be needing some answer. So key found. So this is the key. This is the termination point. If this it is key, found key, and you can display the mid here. The positions you can display even if you want the. You just print it. List. This is binary search.